Okay, kiddos, I'm back, and today we are going to do a review lesson on the structure of the atom. Almost everything we're going to talk about today are things that you have seen in physical science. We don't expect you to know it right away, but if we start to talk about it, it should come back into your mind. So I'm in the guided notes. I'm on page 7 of my guided notes. Zoe, is that zoomed?
Yeah, stop.
Okay. All right, so that's where we're beginning. So page 7, structure of the atom. If you have a periodic table near you, and Zoe, at times I'll probably have you zoom to one of these over here, but a periodic table would help you. So if we do look at this periodic table, so Zoe, if you could just kind of come over this way, we're going to focus on this element right here, but on every periodic table there's going to be some type of key that helps us see what this particular periodic table is telling us. So the key for this one is right down here. So this periodic table is going to be different than the one that we gave you guys, which I think we gave you the first day of class. And it might even be a little different than what I have up here, but just always be looking for a key that helps you. You're doing good. So with this particular setup, the atomic number is this top number, and same thing, it was a top number on that periodic table that's in the classroom. And your atomic number is going to be your number of protons. It's also your number of electrons if the atom is neutral. And right now we're going to say all atoms are neutral, meaning I'm touching it and I'm not getting shocked. There's not a discharge of electrons there. The letter is called your symbol. So this is carbon, and its symbol is a capital C. And just notice when you look at your own periodic table, or Zoe, if you go back over to this one, if there are 2 letters for the symbol, the first one is always capitalized, the second one is always lowercase. Not all symbols are going to have 2 letters to them. Some periodic tables will give you the name. The one in the classroom does not give you the name, but the one on your periodic table that we gave you as a handout does have the name, so that's just the element's name. And this might be different. So this particular symbol in the periodic table is actually telling us the mass number most of the time. So again, so if you could come over here, most of the time periodic tables give you what's called the atomic weight. And Miss Merkus is going to talk about what the average atomic weight is in a different lecture and how we arrive at that. But there are some periodic tables that give you just a straight up mass number for a certain isotope, and mass number is protons and neutrons. Again, these are things that I know we've talked about in freshman science. Whenever we were doing the nuclear unit, we did this type of talk. So we really expect this to be review. If you need to do some additional help with videos or something, you gotta let us know. So whenever we look at this, and again, you might have to pause and fill in what you need. Are you zoomed in enough where you can see that pretty okay? All right. So if we look at the electron, this is just recapping everything. So electron is a -1 charge. If we were to truly look at its mass in grams, so yesterday I talked about how Thomson, and Millikan actually masked the electron. They went down to grams, and think of how small that is. 9.1 times 10 to the -28 grams. So that would be a decimal, 27 zeros before we ever even see the number 9 show up. So super small. We don't like to talk in grams whenever we look at something on a periodic table, so someone has re-quantified that and said, okay, we're going to call that mass something that's called an AMU. And electrons, we basically say have no mass, and we'll get to the why behind it here in a second. Where do we find the electron? In the electron cloud. Okay, I'll come back to this statement here in a bit. Protons are +1. Look at their mass, 1.7. Even though they're still small, they're quite a bit bigger than the electron. 10 to the -24 instead of -28. So that would be like saying 1 gram compared to 10,000 grams. And there's a pretty big difference between 1 gram and 10,000, or between 1 pound and 10,000, okay, to make that connection. Neutron as well has no charge, 1.7 times 10 to the -24. So a proton and a neutron are very much the same. So we give them the same atomic mass unit of a value of 1. And remember, these are both found in the nucleus. So the mass of the atom is found in the nucleus. The electron cloud really doesn't offer or add any mass to it. Does it really have a mass? Yes, it really does. but we say compared to the proton and the neutron is essentially weightless. I think like in ag terms, farm terms, right? So we have really large squares. Whenever we give our horses hay, we have really, really large bales, not the kind you can even pick up. These are like the 1,000-pound bales. And the proton and the neutron, think of that as being like one of those 1,000-pound bales. And the electron would be like one little piece of straw, one little piece of hay that makes up that 1,000-pound bale. It's essentially pointless. Like, what does it matter? If I'm worried about how much hay I have for the winter, I'm probably gonna measure all my large squares. If all of a sudden one of my kids comes up to me and says, hey mom, you forgot this little piece of straw. Don't you wanna weigh that on the scale too to see how much hay you have? I'm gonna be like, really? No, I don't think so. It doesn't even matter. So that's like the electron's weight compared to a proton and a neutron. Proton, neutron, very important as far as weight is concerned. Electron, essentially weightless, okay? What else? Isotopes. Whenever we did a nuclear unit in physical science, we did talk about isotopes. What are they? So they're atoms of an element with the same atomic number, but they have different numbers of neutrons. So this is just a hydrogen example. So we can have hydrogen that has no neutrons. We can have a hydrogen that has one neutron, and we can have a hydrogen that in this case has two neutrons. So, are these, it should have said these, are these the same, and that should have said element in there, that's what your sheet says. Are these the same element? The answer is yes, they're all hydrogen. But there's stuff that's the same and there's stuff that's different about it. So what is the same? Well, they all have the same number of protons, whether it's, and these are just different names for the hydrogen isotopes. So whether it's hydrogen 1, hydrogen 2, or hydrogen 3, they all have the same number of protons, but their numbers of neutrons are different. 0, 1 neutron, and then 2 neutrons. And you can, it's hard to see in your picture, but you can see how the number of the subatomics in the nucleus change. So isotopes are going to give way to creating different masses when we talk about an entire container of hydrogen, because there might be some of this in my container. I might have a little bit of hydrogen 2 in my container, and I might have some hydrogen 1. And that's what Ms. Merkus will get at eventually. But we just need to get kind of good with how do I look at this stuff and how do I actually find the different types of numbers of neutrons and things. I'm going to skip this table for a second. I want to do this one first. So you might, if we have an element, we just call it element X. This is another way we might see the notation. The mass number is going to be at the top in this case, and the atomic number is at the bottom. Remember, mass number is protons and neutrons together. Atomic number is protons only, okay? So this would be just another way that we might see this. And this table kind of speaks to that. So here we have another symbol where the mass number was on the top, the atomic number is on the bottom. So remember, mass number is your protons and your neutrons. If I take my mass number and subtract out my atomic number, that tells me how many neutrons are in that element. So with that top, but this is kind of in the way, isn't it? Are you able to see the table okay, Zoe?
Yeah.
Okay. So with this first one, we have, in fact, I'm just gonna, let's do this, so I can write on here. So with this first one, mass number is the top one. Okay, that's your protons and your neutrons. This is your atomic number, that's your protons only. So if I have a mass number of 1, a proton or atomic number of 1, that tells me if I subtract the 2, I have 0 neutrons. So in here, I would say I have 0 neutrons. I have, remember your atomic number is also your proton number, so I have 1 proton. And your electron count will always mimic your proton count for right now, as long as it's a neutral atom. So I have 1 electron here. Okay, we could do the same idea here. So mass number minus atomic number, that tells me my number of neutrons. So and it's always the neutrons that are kind of confusing. The atomic number is your proton count. So I have 8 protons, and then I also have 8 electrons here, because protons and electrons will always be the same. The thing we don't always know about is the neutrons. They could be the same, they might be different. So here, mass number minus atomic number. So 32 minus 16, this is my neutron count. My proton count's going to be the same as my atomic number. So 16 protons and then 16 electrons. So now we've had 2 examples where everything's the same, but that's not always the case. All all right, here, fluorine. So mass number minus atomic number, 19 minus 9, 10 neutrons. Atomic number is always going to be my proton number, and then my electron number is also equal to proton number. So here's an example, kind of like the first one, where they're not all the same. And then this last one, mass number minus atomic number, 56 minus 26, that's my neutron count. My proton count is always going to be my atomic number, so 26 protons, and then 26 electrons, okay? So if we look to the next page, that has us go over, and you can push pause if you still have to fill some of this in. You don't push pause. But if we look to the next page, I've already lost my little clicker. Oh, it's right here. Thanks. Okay, this tells us, or gives us practice with what we might find. So here's an example. Remember, this is mass number up here. This is atomic number here. So atomic number, it all fills in at the same time. Our atomic number will be the same as this one. Our mass number, that's the top number. Okay, our number of protons and our number of electrons will always be the same as the atomic number. And then this last one, I just do 41 minus 20 to get my neutron count. So this is one way we can write it. So this is one type of isotope notation. Here's another type of isotope notation we haven't talked about, just writing the element with a dash mark. If you see it like this, that is the mass number. So in this case, the only way I know the atomic number is, scroll over here, Zoe, is I've got to have a periodic table in front of me. And I go, okay, so carbon 14, well, remember I just said that 14 is the mass number. The atomic number I get off the periodic table, so if you will, Zoe. Remember, carbon 6, that's the atomic number, so that's what we'll put in right here. And now we just do everything matching up. So atomic number, proton, electron, all the same. Mass number, 14 minus 6. I think that's 8.
Don't ask me.
Okay, so that's how we get this. Let's do another one that's like that. So this 56 is the mass number, so I want to put that here. All right, Zoe, what's the atomic number for iron?
What?
What's the atomic number for iron?
26.
Good job, okay. So we put 26 right here. So if it's written like this, I need a periodic table to help me. So that means we have 26 protons, 26 electrons, and then 56 minus 26, in this case, we have 30 neutrons. I don't know why all of a sudden decided to put it in there, but I did. Okay, we can go in reverse order too. So atomic number is 3. Let's fill in this stuff first. So proton and electron count is 3. And now my neutron is 7 minus 3, so 4. And the atomic number will dictate what the element is. So I want to go over here. I'm looking for atomic number 1, 2, 3, Li. So Li, what is Li? It's lithium, right? So lithium, I can write it one of two ways. I could just write lithium-7, or I could do lithium with a 7 on top and a 3 on the bottom. Okay, both of those are the correct forms of doing that. So you're going to get some practice with that with tonight's homework. So then I said, okay, well, what if we have a situation, and this is what we're going to get into with our next unit when we learn how to name compounds. Sometimes, and a lot of times, these atoms are not happy as neutral elements. This is why we make compounds, and they actually are going to, there's all your answers if you have to check them out. Okay, but they're going to form what's called ions. They're going to form cations and anions. So what is a cation? Okay, so here's the definition and what they are. So how are they formed? They're formed by an atom losing electrons. What are they? They're a positive ion. So I'm going to draw an example. We'll pick something kind of simple. I'll go back to the lithium. So let's say that we had lithium-7. That'll work good enough. And lithium-7 has 3 protons in it. I'll make those this color. And then it has 4 neutrons. And that's all inside the nucleus. And then lithium-7 out here, I'm just going to pretend like there's an electron cloud somewhere out here. has 1, 2, 3 electrons. So remember that your protons are these purple ones. So we now have at this moment, I have 3 positive charges. And I have 3 negative charges. If a cation is formed by electrons leaving, let's watch what happens. So let's say that this electron literally escapes, it leaves. And we'll talk in later units why that happens, what occurs. So if that electron leaves, what's the overall charge? Well, this is now gone. So before, whenever they could cancel each other out, this electron is now out of here. So this positive and negative cancels, this positive and negative cancels, nothing cancels out this positive. So you're left with an overall positive 1 charge. So that's how a cation forms, is electrons leave, overall positive charge, okay? The last thing we want to talk about today are anions. So what are they, and then how are they formed? So let's get that definition in. So anions, what are they? They're formed by an atom gaining electrons, and they're a negative ion. So I'm going to pick on, we'll use oxygen. And let's say that we have maybe oxygen 16. So if I were to try and draw what oxygen 16 is going to look like. Now it gets a little messy because there's quite a bit of protons in there, right? So there's 8 protons. So I'm just going to write it like this right now. And then I would have 8 neutrons. This would all be in the nucleus. And then somewhere out here, okay, we have a total of 8 electrons. So I'm just going to draw these in as little negative charges. Okay, 8. So at the very beginning, right now, we have 8 protons, we have 8 electrons. So what is a negative ion? Well, how's it formed? By extra electrons coming in. We'll learn later where those electrons come from. For right now, just trust me. So let's say that we have another electron that comes in here. So we have added now, instead of having 8 electrons, we've added a 9th one. So what does that mean? These cancel, cancel, cancel. All of these cancel except for this one new electron that got added in. We'll talk later where that came from. And now we have an overall negative 1 charge in this case. And you could have 1 electron coming in depending on the atom. You could have 2 electrons coming in. If that's the case, that would be a negative 2 charge. And that's really what oxygen does, is it has 2 electrons that normally fly in. But that's an anion. Negative charge gains electrons. Kind of feels opposite. Okay, that's it for this lesson. You're going to see your homework assignment. Go and do that, check your answers, and we'll see you again soon. Thank you, Zoe.